Hi, so today we'll be discussing about antifungals. Okay, so this topic is, I'm not going to go really deep into it, but going to keep it as simple as I can. Most of this is from online med and first aid. So if you really want to dig deep and read the nitty gritty, just go there and check the lecture out or read the book. Okay, so let's start with why this topic is important. Okay, now antifungals are important because fungal cells are eukaryotic. That means they're very similar to human cells. That means they'll have a nucleus, mitochondria, and they utilize ATS ribosome. The most important thing about this is going to be the P450 interaction, the hepatotoxic and everything. So if you ever get a question in usmle, it's always going to be this. Okay, so the most important part is antifungals because we'll be discussing antifungals, right? So you are going to come up with drugs with different strategies, the area where they should attack, right? So the first thing we'll do is plasma membrane, the cell wall, the mitotic spindle, and then DNA and RNA antimetabolites. These are the sites where we will attack the fungus. Now I'll just don't waste your time writing or copying this down. I'm just going to put this exact same thing. I'll put the link to the Google Drive or something, PDF, down in the description box. Just check that. Don't waste your time writing because I have already put a lot of efforts and wasted my time writing this. So you should not do that. Okay, so now the plasma membrane, humans have it, fungus has it. Have hold on, are you recording? Yeah. So both of them are going to have, okay, you have cholesterol in the plasma membrane of humans while you have ergosterol in the plasma membrane of the fungus. This is the difference of this is going to make us able to attack the fungus ergosterol. What is the role of ergosterol or cholesterol in our cell? It gives plasma membrane the fluidity. So when we are giving any drug that will target ergosterol, it will cause plasma membrane stress. To understand this, you need to understand how is ergosterol made. Okay, you have squalene. I am going to go in the very high yield material only. I'm not going to discuss the very deep stuff because I feel that's not clinically relevant right now and you cannot memorize all of it. If you want to go and read some other resource where they teach you everything in depth. Okay, you have squalene. Squalene will turn it into lannosterol to ergosterol. Now, there are a lot of steps in the middle of this, but the most important is squalene, lannosterol, ergosterol, SLE. Okay, so squalene to lannosterol is from squalene epoxide. This we target the terbinafine, okay, terbinephrine, and lannosterol to ergosterol will be by 14 alpha demethylase. Just remember this, we'll discuss the drugs in a minute. Okay, now the cell wall of fungus is made of chitin and beta glucans. Now, there it is like the cross link that we have in bacterial cell, it's similar, but this will be 1,3 beta glucan linked with 1,6 beta glucan. Now, for this cross linking, the most important thing is going to be 1,3 beta glucan synthase. This enzyme is very important for the cell wall integrity. Over here, you'll have echinocandins, which will attack the cell wall. Okay. The next part is mitotic spindle. This is important for uh, replication, mitosis, meiosis, all of that. Griseofulvin is going to attack the mitotic spindle. Now, griseofulvin is very teratogenic and it is never the right answer. So, read about griseofulvin, but most of the times it's not going to be the right answer. They'll ask you the side effects, which is teratogenic, blah blah blah. Go read that. Okay, and when we go down, you have antimetabolites, which is flucytosine. Now let's go one by one to the drugs. Okay, in the first thing that we discussed was plasma membrane stability, which was by ergosterol. Now, how do we create stress? Is attack this ergosterol by this pathway. So the first part was squalene. Squalene is made into lanosterol by squalene epoxidase. Now, this is allylamines and benzylamines are going to convert squalene into lanosterol. So this is terbinafine is going to do that. Now the terbinafine you can use for only 2 to 4 weeks, and it is always going to be topical. Topical is going to be similar to clotrimazole, which we'll discuss down. And the most important part is going to be when you have okinomycosis. God, these words are very difficult for me to pronounce. So okinomycosis is when your nail is infected with fungus. That time you will give oral terbinafine. The only time you will give this orally. The next, okay, this is most important because okinomycosis is when the fungus is growing inside the dead cells or the keratin, and terbinafine can get accumulated over there. So that is important there. Now the second part is lanosterol, which was converted into ergosterol by 14 alpha demethylase. Over here, this enzyme is attacked by your azoles. Now you have two types of azoles, amidazoles and triazoles. Amidazoles, all of them are always going to be topical because if you give them orally, they will cause interactions of P450, hepatotoxic, and impaired androgen synthesis, which will lead to gynecomastia. Okay, over here you'll have ketoconazole, miconazole, and clotrimazole. These are all dermatophytes. That means you'll have these in cream forms. Okay, now triazoles. Now these, you have three drugs that you need to remember. Okay, the adverse effect is going to be gynecomastia, similar to this, impaired androgen synthesis. Now triazoles can be given orally or IV. You need to remember that if you have any kind of life-threatening disseminated disease, you will give amphotericin. Amphotericin is the worst medicine that can ever be. So if anything goes wrong, for the worst fungal infection which are disseminated or life-threatening, you will give amphotericin B. Coming back over here, you will have fluconazole for invasive candidiasis. Invasive candidiasis is not disseminated candidiasis. This candidiasis, you can give it orally or IV. Voriconazole is going to be for aspergillus, which is invasive. So aspergilloma, aspergillus bronchopulmonary allergic reaction and all that. You can give it oral or IV. And itraconazole for dimorphic fungi, which is invasive again, not disseminated. So all the triazoles are going to be for don't get confused here. All the triazoles are always for invasive. And for anything, if you ever see that something is disseminated or life-threatening, you will go for amphotericin. Otherwise, you go over here. Okay, so the last step of ergosterol formation was ergosterol. Over here, you'll have polyenes, ergosterol polyenes. The two most important ones are amphotericin and nystatin. Now nystatin is really small, so let's get done with that. Nystatin is so toxic that if you give nystatin IV ever to anybody along with a fungus, it will kill the entire human. So nystatin is always going to be topical, like candidal infections. Something IV matlab it goes in the blood vessels. But if you give something orally, it goes into your GI tract and not into your blood vessels. So there are two ways. So the only way you use topical nystatin is going to be for candidal, oral thrush, vaginal. And swish and spit is gargle and spit for oral candidiasis, swish and swallow for esophageal candidiasis. Okay, we're done with nystatin. Now, the last step of ergosterol again, polyenes. You go for amphotericin, the big gun, the worst one, the last resort for the most life-threatening fungal infection. That means disseminated infections where you have very severe infection. This drug was used a lot through the COVID times for mucor. If you are an Indian student or if you worked in the COVID times, you will know that. Okay, any fungus can be killed with this drug, but it also kills the kidneys because this has renal excretion. So you need to make sure that you're not using amphotericin B to anybody. It's always IV amphotericin, right? Now you'll cause disseminated infection by anything. These are the most common disseminated infections, but any time that you have a very severe disseminated life-threatening infection, go for amphotericin. It is nephrotoxic. Why? So when it binds, when amphotericin B binds to your ergosterol, it forms a pore. This is one thing. It will also call pre-renal azotemia, and the toxicity is dose and time dependent, killing of the tubules, renal tubules. But this I mean. And because it has renal excretion and irreversible damage, what happens is, uh, okay, I've written it here, but I'll explain it to you again. Now, amphotericin B is going to attack your ergosterol, right? It will also attack similarly your cholesterol. So in your blood, if ergosterol is not present, amphotericin B is going to attach to cholesterol and kill your tissues. So what we do is you bind amphotericin B to a third lipid. So this is called liposomal amphotericin. So what happens is if ergosterol is not there, the amphotericin if ergosterol is not there, the amphotericin will bind to a lipid and not to the cholesterol. And this will save our human tissues. That is amphotericin. Now when we're coming to the cell wall, we discussed that 1,3 beta glucan synthase which will be inhibited by ecocandidins. I've written it here again. So these are very safe. They hardly have any side effects, but you need to remember the indications. Mycofungin for candidemia, that is disseminated candidiasis, and caspofungin is for neutropenic fever, which is usually pyrexia of unknown origin, that you have more than 7 days, you don't know what the source of the fever is, there's neutropenia, and you'll give caspofungin. Okay, these will lead to cell wall stress, and we talked about this. Okay, the last one was flucytosine. Now, what does flucytosine do? It goes to the DNA, RNA metabolites, and it will not cause metabolites. What happens is, why is flucytosine so good? Flucytosine is a prodrug. That means it goes inside the fungal cell, only inside the fungal cell, and gets converted to 5-fluorouracil. It cannot go inside the human cell mostly. And even if it does, very small amount of flucytosine will go in, and still a lot less amount is going to be converted to 5-fluorouracil. Now in DNA synthesis, uracil is converted to thymine. Okay, but with this XYZ enzyme, uracil to thymine. But instead of uracil, if you're giving fluorouracil, it can't be converted to thymine, right? So this will not happen, and there will be, it acts as an antimetabolite by inhibiting transcription and metabolism. The only time that you'll see flucytosine being used is cryptococcal meningitis. What you do is you give, because cryptococcal meningitis is very severe, life-threatening and disseminated. Which drug do we give? We always give Ampho B. And with Ampho B, you will give flucytosine as an inducing agent to be an antimetabolite. So this is your antifungals. The first thing that you need to know is these P450 interaction, because it is important. How does it attack? It attacks the plasma membrane, the cell wall, mitotic spindle, and the DNA translation by flucytosine. Okay, how the plasma membrane? By the ergosterol, squalene, lanosterol, ergosterol. Squalene epoxide is going to be terbinafine. Lanosterol to ergosterol by 14 alpha D methylase by Euler azoles. The first group is amidazoles, which were topical only because they have a lot of hepatotoxicity, blah blah toxicity, will always be topical for dermatophyte infection, ringworm, tinea. Triazoles were always oral. Okay, these will also give gynecomastia. Fluconazole, candidiasis, which is invasive. Voriconazole for aspergillus of different types, invasive, not disseminated. Itraconazole for dimorphic fungi. Triazoles only for invasive, not disseminated. When we go to the last step, ergosterol is inhibited by polyenes, which is amphobi and nystatin. Nystatin is always going to be given topically because it will kill human. It's very toxic. Only topical. Swash and split or swish and swallow for oral or esophageal candidiasis. That's all. Amphotericin B, very, very, very nephrotoxic. You'll always give it for life-threatening, very bad infections. It will kill any fungus, but also human kidneys. It is the last resort that you'd want to use for the most severe cases. It is nephrotoxic, dose and time dependent because it has renal excretion. It also will cause irreversible damage. So what you do is attach the amphotericin B to another lipid so that instead of binding to the cholesterol, it binds to the lipid that we added. The last thing was mitotic spindle, griseofulvin, always a wrong answer. Cell wall, which is made up of chitin and beta glucans. 1,3 beta glucan is linked to 1,6 beta glucan by this enzyme called 1,3 beta glucan synthase. It hardly has any side effects. The ecocandidians, which will cause cell wall stress, mycofungin, candidemia, caspofungin, neutropenic fever, and we discussed everything. This is all that you need to know about antifungals to start with.